Hello, welcome to Taxonomy Online Mathematics. We are having tutorial on the topic matrix, and in this video we'll be taking the inverse of a 2 by 2 matrix. If you are new, consider subscribing to the channel, like, share, and comment. Now, we all know that in mathematics, inverse is simply the reciprocal of a number. So if in case we are asked to find the reciprocal of this, reciprocal of A is going to be 1 over what? A. Is that what it is? That's reciprocal. Now, this taken into indices can also be written as what? A exponent 1. So in all, if this is the matrix, then this become what? The inverse. So the inverse of a matrix is just what? The reciprocal of the matrix. So by symbol, we represent a prime of negative to a matrix in order to call it the inverse. But under 2 by 2, we are going to take it in a different way. So we suppose that the A, which is the matrix given to us, is having the element A, B, C, D. Then if this is the image, which is we are calling the inverse, let's say the inverse of A is also giving, let's continue, E, F, G, what? H. So if this is the matrix, then this is the image. We know that if I multiply this by this, as in A times 1 over A will cancel, I'll be left with 1. And we call it the identity. So in normal calculation, the identity is going to be 1. 1 is the identity of a number if the reciprocal multiply the number. Identity element or identity matrix, which is called the unit matrix. And that is going to be a matrix that have the leading diagonal to be what? Also indicated with I as identity. So we know that if I multiply the matrix by its image or by its inverse, we know this is the same as the inverse as we are having. I should be having something called what? The identity matrix, or better still, the unit matrix. So if that is the case, what is A? A is this, so I can have this to be A, B, C, D. I believe this is multiplication. So let's multiply our inverse. Inverse. E, F, G, H. We should be having the identity, the unit matrix, which is 1, 0, 0, 1. That's the meaning if we are to borrow the ideas from general mathematics. So the concept is that the matrix times each image should give us what? The identity. Good. Per multiplication, we also know that the row will multiply column. So A, E plus B, G, right? This is going to be the first entry. And we know this entry is on the left equals to the right. So the first entry will also equal to the first entry here from equality of vectors. Equality of what? Matrix. Alright, so this is going to be equals to 1. We can call that equation 1. Then for the second entry, we know it will be row times column. So A times this will be AF plus B times this will be what? H. That's also equals to the second entry, which will be 0. Equation 2. Are you with me? So we are going for the third entry here. So this is going to be row times column CE. So let's say we have CE plus DG. So I'll be having DG or GD. All equals to the third entry, 0, equation 3. I believe this will still go to the other side to give me CF plus DH should give me the last entry 1, equation 4. So we're having 4 equations. Let's remember that in this you will be asked to find this, whereby this will be given to you, meaning the matrix will be given, you will be asked to find the inverse. So it means that the matrix have values 1, 2, 3, 4, 5. These are unknown quantities we are yet to find. So we hold those value E, F, G, A's as unknown quantity, A, B, C, D as quantity we already know. So we are not interested in that. Our task is to find this from the matrix. So I can see that equation 1 and equation 2 have so many variables. A, E, A, F, B, G, 4 sets. If I look at A and E, there is E, A, that is equation 1 and 3. I see A, E is here, G is here, G is here. So E, G, G, which are the values we are looking for. So I will solve equation 1 and equation 3 simultaneously. So let me write them. So with this equation, we are interested in the E, which are the variable. You can see it. If it is 4x plus 3y, it will be 10x plus what? Something y. So we can see those variables are there. So I am interested in that. So I need to be able to eliminate. I need to make sure the coefficients are the same. So if I want to eliminate the E, I will multiply equation 1 by what? C. So I'm going to have equation 1 by C will give me ACE plus BCG equals to C times this is what? C. Then equation 2, in this case, I'm taking that as 1 and 2, so forget about the 3. So equation 2 will also have A, multiplying it. So if A multiply this, ACE plus ADG equals to 0. So now holding E as a variable, AC are the same. So if I perform subtraction, all of this will go. So let's say equation 3 and 4. We are going to have equation 4 minus equation 3. That will give me ADG minus what? BCG equals to, it is this minus this, right? So I'll have minus what? C. Right? Good. So in this case, I have GG. So I take the G out. I'll be left with AD minus BC equals to minus C. I need the G. So what do? I divide through by the bracket. So G is going to be minus C AD minus what? BC. But from previous lesson, we know AD minus BC is determinant. So I can still write this as minus C over what? Determinant of the matrix A. Do we get it? Okay. I can put this back into any of the equations to find the order, but I would prefer to use multiplication again. So I want to eliminate G. So I'll swap their coefficient. So equation 1 times what? D. So I'll be having ADE plus A, not A, it will be BDG. This is multiplying there, equals to D is multiplying, I have D. This B will also in turn multiply equation 2. So B here, I'll be having BCE plus BDG equals to 0 per that multiplication. So let me continue equation 5. Equation what? 6. Per subtraction, I am seeing that if I subtract, BDG will go. So equation 5 minus equation 6 will have ADE here, BCE equals to only D, because it is this minus this. D minus 0 is what? D. Can I be able to factorize? What am I going to find as a factorization? E can go out. Then I'll be left with AD minus BC equals what? D. Alright, so if I have that, I can also find E. In this case, so from here, your E is going to be D over ADBC, D over the determinant of A. I believe we are done with equation 1 and 3. So now we are going to take equation 2 and 4. So solving equation 2 and 4, I can also see that FF, HH are the variable. So we are going to use the A, B, C, D as what? As constant. So if I want to eliminate I want to eliminate F, it means I'll alternate. So it means C, from here we'll multiply this, will give you ACF plus BCH equals to 0. Then this A will also come to multiply. ACF plus is multiplying this, so ADH equals to what? A. You know, A will multiply this, will give you that. So let's say we continue equation 7, equation 8. What will we be seeing? ACF, ACF. If I subtract, they'll go. So let's say equation 8 minus equation 7, we'll be having ADH, which is this, minus BCH equals to, it is this minus this. So I'll be having only what? A. Are you okay with that? So now, what do I have? Common factor H into bracket AD equals to A. So I think from here, I can say that H is equals to A all over AD BC. A is the same as the determinant of A. So now we can also now eliminate the values of what? H, so that we can get what? The value of F from that equation. Or if I like, I can put this into any of the equation. The equation 4 was AF plus what? BH equals to 0, right? So if I put H here, it's going to be AF plus BH, which is A over AD BC equals to 0. I need the value of this, so I'm taking my time because the board is not that big. So I need to do substitution so that I've cleaned equation 4 and 5. So that one is gone. So we need to be able to use what we have on the board. So per multiplication, what are we going to get? This is the F I'm looking for. So AF will maintain here. All these are going there. So I'll be having minus B A all over AD BC. So you can see that if I divide through by A will come here and cancel that. So my F will just be minus B all over AD BC minus B determinant of what? A. So in all, I know the value of what? E. The value of E is known. F is known. The value of G is known. And H, I believe, is also known. So what will I do? I am looking for the inverse. So let me replace that. So our inverse, which is E, F, G, H, the value of E. What did we get for the value of E? We get this. D over that A, the value of F. What do I get? Minus B, that's A. That of G, I have here to be minus C, determinant A. H. Where do I get H? A over determinants what? A. You can see in that first entry, second, third, fourth, they all have denominator of what? Determinant A. Meaning it is 1 over determinant that is multiplying that. So if I want to factorize, if I factorize this, so A, this is the same as this. I'll be having 1 over that A multiplying only D minus B minus C and what? A. That is the only thing I'll be left. So this is going to be our determinant, which is the same as AD minus what? BC. Good. Then when we come to this, we call this the adjoint. Of matrix A. That's the adjoint. What it means is that we can see in the beginning A, B, C, D was the matrix A. The adjoint is just the position of A and D has been swapped. We change this position, then we negate. We negate this. So C minus, B minus. Then position of this will change. Alright. Now, how this also come about, having this, we will explain that when it comes to matrix inverse of 3 by 3. For the inverse of 3 by 3, we can't use this approach. We have to use the minus, the transpose, and the cofactor. I will explain this concept again. How come it become negative, negative, and we swap this. Okay, let's see, we have this. We have to find inverse of A. So this is the formula we are going to use to find the inverse of A. 1 over determinant. Then we solve the position, negate. So in this case, my determinant of A is going to be product of this, which is what? 0 minus this 3. So I have minus 3, right? Okay. So if that is out of the way, what do? I need to find the inverse of this to be 1 over minus 3 multiplying the swapping the position. Negative 1, negative 3. So this is the inverse. If I want to make them to become compact, it become, I have 0. This will come on top of this. So I have plus 1. This become 1 over 3 minus 4 over 3 as our inverse. So you see that it is easy to calculate. The reason why we went through all this is to get the understanding of how the formula is derived. I believe you have followed, even though the video is a bit lengthy and maybe slow, you still follow to the end. So this, any questions in this form, you should be able to calculate that. It has been a pleasure serving you. If you like the video, don't forget to like it. If you are new, subscribe, share with somebody, and leave a comment for us to get interactive. Bye-bye.